So hello friends, in this video we are going to study the instruction set of 8085 and we are going to see the arithmetic instructions. Okay, so we are going to start with arithmetic instructions. So the first arithmetic instruction we are going to study here is add register. So here R stands for the register. So this register will contain the operand which has to be added with the contents of accumulator. So in the last video we have seen that if you want to conduct any arithmetic or logical operation, the first thing we have to do is what? One operand we must have to store in accumulator, because the speciality of accumulator is what? Accumulator will contain one of the operand during any arithmetic or logical operation, and afterwards when the processor executes that operation, by default the result will be stored in accumulator. So this is the first standard format that we are going to study in this video. So this is add R. So add stands for addition. Okay. So what this instruction will do? This instruction will add the content of the register which is specified in the instruction with the contents of accumulator. So we should know that one of the operand is always stored in accumulator. Okay. So accumulator is going to role a vital role in arithmetic instructions. So for example, if I will write the instruction add B. Okay. So if I will write the instruction add B, and suppose A is consisting of 0, 2 and B is consisting of 0, 4. Okay. So all these two numbers will be the hex numbers. So H is representing this number is as a hex number and not the decimal number. So after the execution of this instruction, what will happen? The contents of B register, that is 0, 4, will be added with the contents of accumulator, and then the accumulator will be updated with the result. So 0, 2 plus 0, 4 will be equal to 0, 6 H. So after execution of this instruction, now accumulator will be added, updated like with 0, 6, because the result of the addition is what? 0, 2 plus 0, 4, that will be equal to 0, 6. So this is a simple instruction, that is the first standard format from the arithmetic group. Okay. Now the next standard format we'll see here is, the next standard format is ADI 8-bit data. Okay, ADI 8-bit data. So in the last video I have given you the hint that whenever any instruction will consisting of I, it indicates that the instruction is going to consist of an immediate number. Okay. So ADI 8-bit data. The meaning is add the immediate number which is specified in the instruction. Add the immediate number which is specified in the instruction with the contents of accumulator. That is, if suppose if I am going to write ADI 0 to H. So in this case 0, 2 is the immediate number. This is the second operand. And where will be the first operand? The first operand is nothing but the contents of accumulator. So suppose in this case if accumulator is consisting of 0, 3 H, then after the execution of ADI 0, 2, accumulator will be modified to 0, 2 plus 0, 3, that is A will become now 0, 5 H. Because what happened here, the immediate number 0, 2 is added with the original contents of accumulator, that is 0, 3, and will get total result 0, 5. So this is the second standard format. First standard format is add R. The second standard format is ADI 8-bit data. Now the third standard format here we are going to see is ADC register. ADC register. So what it stands for? AD stands for addition. Register, this register will be from any of the 7 registers which are accessible to the user, that is accumulator, B register, C register, D, E or H, L. Or we can write here another standard format as ADCM. So we have already know about what you mean by M. So M will be the memory location whose address is present in HL pair. So HL pair, whatever be the address is present in HL pair, that memory location can be treated as a M register. So this is the next standard format. So for example, if suppose the carry flag is 1. If suppose the carry flag is 1 and accumulator is consisting of 03H. Okay. Accumulator is consisting of 03H. Okay. Carry flag we should mention because carry flag is a single bit flag. So if carry flag is 1 and accumulator is consisting of 03H, and if we are going to write the instruction A, B, C, B. So what will happen? The contents of B register will be added with the contents of accumulator along with carry flag. And if suppose in this case B is 04H, then what is going to happen? In this case, the addition of these 3 bits will take place. That is, accumulator will be added with the B register plus the carry flag will be added to this. So after the execution of this instruction, accumulator will be updated with the addition of these 3 bits. Okay. So 03 plus 04 is 07 plus 1. So accumulator will become 08H. Accumulator will become 08H because 4 plus 3 is 7. 3 plus carry flag has to be added. So it will become 08H. Okay. So here we have completed the instructions related with the addition operation. One more standard format is there, which is ACI 8-bit data. Okay. ACI 8-bit data. So similar to ADC, here the contents of register will be added with the contents of accumulator along with carry flag. In this case, the given 8-bit number will be added with the contents of accumulator along with carry flag. That is the change only. So the given 8-bit number will be added with the contents of accumulator along with carry flag. So these 4 standard formats will be having to perform the addition operation. So what we have seen in this video, we have started with the arithmetic group of 8085, and in that the standard formats which are used for the addition operation, addition of 2 8-bit numbers can be performed with the help of these 4 standard formats. Thank you.